In this lecture, we're going to explore how virtual functions or polymorphism plays with default arguments. And when we say default arguments, we mean a setup like this. We have a virtual function here, which is called add. It is going to return double, and it has default parameters here for a and b, and the value is 5 here. In our derived class, we also have the same function. We are overriding that, and we have a different set of values acting as our default parameter here. We are using 10 for a and b here, and we want to see how this plays with polymorphism. Now, please note that with polymorphism, if we go through a base pointer to manage a derived class object, what we want is to call the most specific implementation of the virtual function here. For example, if we have a base pointer managing a derived object, and we call the add method from a base pointer, we will get the most specific method here called. But what you get with these default arguments is that the compiler is going to use static binding to decide which default parameters to pass to your function. So even if you will get this method here called, the compiler will still use the default arguments we have in our base class. So we will call this method here, but we will use the default arguments coming from the base class, and this is a behavior you need to be aware of. Okay, so another way to put this is that default arguments are handled at compile time. The compiler is going to wire these things at compile time where you are building your application, and the virtual functions are called at runtime with polymorphism. So if you use default arguments with virtual functions, you might get weird results with polymorphism, because the default arguments you will be using are going to be decided by static binding, but the actual function that you get called is going to be decided by dynamic binding. So we will call the virtual function in our derived class, but we will be using the default argument from the base class. This is the behavior we'll get. You need to be aware of this and make sure this is what you desire. My personal preference is to not use default parameters or default arguments with virtual functions, because this is really going to make my code hard to follow and hard to understand, especially for other developers that might have to work on my code base in the future. Okay, here is a simple example. We have a base pointer which is going to be managing a derived object, and we will call the add function here. What do we expect to get? Well, because we have polymorphism here, we will call the most specific add function here, and that's going to be the add function from our derived class. But the default argument we pass are not going to be decided by the derived class. The default arguments are going to be plugged in at compile time using static binding. So because the base pointer is a base object, we will be using the default arguments from the base implementation of the add method. So we will just plug in 5 and 5. So we will add 5 to 5 and add a 2. That's why we get a 12 right here. And if we go through base references, we will get the same result, because this is going to enable or trigger polymorphic behavior in our C++ programs. If we go through direct objects, we will be doing static binding, and we will use the default arguments or default parameters from our derived object. And remember that we use the value of 10 in there, so we are going to add 10 to 10 and add a 2, and we are going to get a 22, as you see here, through static binding. If we do slicing by assigning a derived object to a base object, the derived information is going to be sliced off. And if we add, we will use the default parameters from the base class, and we will use the implementation in the base class. So if we come back to our code here, we will use the default arguments from the base class, and that's a 5 and a 5. We're going to add them up because the body is going to be from the base class. Remember, the derived information has been completely sliced off. So we are going to add a 5 and a 5 and a 1, and we're going to get 11 printed out if we do slicing. And that's the result we get right here. As a closing note before we head over to Visual Studio Code, again, default arguments with virtual functions can be very confusing. They are best avoided because they really are going to give a hard time to anybody that is going to be working on your code in the future. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is virtual functions with default arguments. We're going to grab the code from our template project. We're going to copy this and put this in the current project. And I am going to grab my classes, base and derived that we are going to be using here. If you don't want to type along, you can grab the source code from the resource section of the course. If you don't want to type all these classes or create them, you can grab the source code from the resource section. On this lecture, you're going to download this and use this. You don't have to waste time typing these things because many of these things are already familiar to you. We're going to open this in Visual Studio Code and we're going to have our classes here. We have a base class, which is going to have a virtual function with a pair of default arguments here. We are using 5 in our add virtual function here. And if we go in derived, it is going to derive publicly from base, and it is going to override our virtual function here. But notice that it is going to set up its own default parameters. So if we do polymorphism and use a base pointer to call the add method here, we will get the most specific or the most specialized version of the add method called, and this is going to call this body here, but the parameters are going to be decided by static binding. So because we will be going through a base pointer, we will use the default arguments from the base class. That's going to be 5, and we're going to play with this and see what this is going to give us in the main CPP file here. Let's clean up a little bit. We're going to remove whatever we don't need here. And we are going to include our derived class. We can do that. We are going to put in our code to really play with us. Let's remove these spaces because we don't need them. We are going to go through a base pointer to manage a derived object. And this is a setup we can use to put things in place here. We are going to call the add method. Notice that we are not passing in any parameter because we are going through a base pointer and the add method is virtual. Polymorphism will kick in and we will get the derived version of our add function called. So we will call this add function here, but be careful because we won't be using these default parameters here. If we did, we would add a 10 to a 10 and get a 22 in our main function here, but that's not going to be the case. The compiler is going to use static binding to decide which default parameters to use, either those in the base class or those in the derived class. And notice that if we hover over this add function, you see that the compiler has plugged in those from the base class, and that's what the compiler is going to do. So it is going to add a 5 to a 5, and it is going to add 2 to that. I think that's what we are doing in our derived version, and we are going to get a 12 printed out. Let's build and see if this is actually the case. We're going to pass this through GCC, and that's the compiler. That is our favorite now. The build is going to be good. We can close this and bring up a PowerShell window. And if we run Rooster, we're going to see that derived add was called and the result was 12 here. This is what we get. Again, the compiler is going to call the most specialized virtual function override here, but it is going to use the default parameters from the base class. You should really know this. And this can really be confusing, especially if you are a beginner to polymorphism. If we go through a base reference, we will also get polymorphic behavior. So if we have a derived object and we set up a reference to that, which is of type base, and we go through that base reference and call the add method, we will get the most specialized add version called. So that's going to be derived add, but we will use the default parameters from the base class because which default arguments we use is decided by using static binding, and that's what we get here. And Visual Studio Code is really helpful here because if we hover over the add function, we're going to see which default parameters were plugged in by the compiler, and you see that they are those from the base class. So we are again going to add 5 to a 5, and we are going to add a 2, and we will get 12 printed out here. If we build and run, we're going to see that this is the case. The build is good, we can clear and run Rooster. We're going to see that with a base reference, we're also going to get a 12. We will get the most specific implementation of the add method called, but we will plug in the default parameters from the base class. I really want this to be super clear. If you set up things in a way that you are going to get static binding, then if you are going through a base object, you will call the base version of the add method and you will use the default parameters from the base class. If you happen to be manipulating a derived object, you will use the information in the derived class. The derived version of the add method is going to be called, and we are going to use the default argument from the derived class. So if we set up another example here, we can set up a base object, for example. We're going to say base and say base 3. We can do that. And we try to call the add method. We can say base 3 and say add. We can try and store this in our result variable and we can print this out. We're going to say stdcout row result. We can say something like this. And we're going to print out the result here. If we build and run, we're going to see that this is going to call the base version of the add method and it is going to use the default parameters from the base. If we go back to base, we're going to see that we are going to add a 5 to a 5 and we will get 11 because we will plug in a 1 and return the result here. Let's build and run and see that this is actually the case. So this is going to be completely doing static binding. Let's clear and run. You see that the build is good. We're going to run Rooster and we will get 11 printed out here. Hopefully you can see this. If you assign a derived object to a base object, you will get slicing. Let's see that we can actually do this. But before we do that, I also want you to see that you can also do row direct objects of derived classes. If you do this, you will get the information from the derived class. We will use the body from the derived class and we will use the default parameters from the derived class. So we will take 10 and add a 10 and we will add a 2 to that and we will get a 22 printed out. I think we can do this. So let's put in a separator because that's going to make it easier to follow these things. And we're going to build with GCC. The build is going to be good. Hopefully the build is good. We can clear and run Rooster and we're going to see that we get a 22 here. If we assign a derived object to a base object directly by doing something like this, I think we don't need this guy here. We can remove this. We have a base object that we are setting up here, and we are assigning a derived object to this base object here. If we call the add method, we will get the version from the base class because, mind your steps, this is going to slice off all the derived information because we are not going through any kind of base or reference. So this is going to slice off all the information we have in the derived object here, and we will be left with the base information. And if we call the add function here, you see that we are using the default parameters from the base class, and we will use the body of the base class implementation here. So we will add a 5 to a 5 and we will add 1 to that. And we will get 11 printed out as we see here. Let's build and actually prove this. We're going to pass this through GCC. The build is going to be good. We can clear and run Rooster and we are going to see that the result is 11 if we do row object assignment here. This is really all I wanted you to see in this lecture. That you should really be careful if you are using virtual functions mixed up with default arguments. The compiler is not going to do dynamic binding on the default parameters. It is going to decide which default parameters to plug in at compile time using static binding. So the compiler is basically going to look at the type of the pointer or object that you have, and it is going to use that to decide which default parameters to plug in. So at this example here, for example, at line 7, it is going to see what kind of pointer do I have. I have a base pointer, so I am going to use the default parameters from the base implementation. And if you hover over here, you're going to see that it is going to plug in a 5 and a 5. Even if we are using the most specialized add version in our inheritance hierarchy, the compiler is going to still use the default arguments from the base implementation. Down here on line 16, the compiler is going to say which kind of reference do I have. It's going to say base because that's what we have here. So it is going to use the default parameters from base, and that's what it is going to plug in here, 5 and a 5, and we're going to get this result here. Down here on line 25, the compiler is going to see which kind of object do I have here. Base 3 is a base, so I am going to use the default parameters from base. Down below on line 31, the compiler is going to look and see which kind of object do I have here. The object is derived, so I will plug in the default parameters for derived. Again, this is really what the compiler is going to do. With default parameters, the compiler is never going to do dynamic binding. And this is going to make your code really confusing. Again, my advice is to avoid default arguments or default parameters if you are using polymorphism in your inheritance hierarchy. We are going to stop here in this lecture. In the next one, we're going to learn about virtual destructors. Go ahead and finish up here and meet me there.